Welcome to Savoir Labs. I'm Jamie Goodyear. Have you been trying to introduce AI to your backend services in the hope that it will be able to figure out what backend calls to use to perform actions for you? Well, LangChain4j has you covered. Up next. LangChain4j is a Java-based library for supercharging your applications with AI capabilities. In this video, we're going to focus on the feature called Tools. In other platforms, they're calling it function calling. Essentially, what you need to know is the ability of the LLM to call out to your methods, your application code, to perform business logic. Let's take a look at an example. In a prior video, we discussed the concept of an API gateway and how enterprises use those to simplify and consolidate all of their APIs, interfaces that clients need to use to be able to reach backend services. So effectively, the client just needs to know about that API gateway and its interface, and then it is ready to do work and request jobs, and everything is great. The complexity behind the scenes is going to be backend services that could talk to, say, databases, Kafka streams, maybe talking to a JMS broker, and composing all these calls together to be able to do real work. What's interesting here then is when we introduce an AI to the system. At first, we were just introducing how would you even talk to a external AI or to something that's running locally, say something that runs on Ollama. Well, once you have those connected and you can talk to it, say, conversationally, the next thing you're going to want to do is say, well, can the AI perform things for us? Can it become aware of what all these backend services that the API gateway is handling for us and start using those to do jobs? I want to talk to it and say, I want to do some work and make it use those backend calls. So how do we do this? Well, LangChain4j has some really cool functionality here. It's called Tools. And what it will allow us to do is add in a description to our service to say, hey, this is what this particular call does, and we can decorate that with additional information so it can start using it. Let's dive into a demo so we get a better idea of how this works. Let's dive into the code we have for this project and then run the demo. So in here, we have two modules. The first one is what we're calling an existing service. The only thing you need to know about it is that it has an API, which is telling us about converting some kind of a string. I'm using this to represent, say, if you had a XML file and you had it in schema 1, you want to go up to the latest schema and it would handle all the conversion required for that. The implementation under the hood is just going to be doing a uppercase string. This is just representational. It doesn't need to be doing anything heavy, but we have something that's business logic. Our plugin for Ollama, what this one is going to do is going to show how we can talk to Ollama running locally on our network. And then the extra pieces we're going to decorate it with to be able to make it aware of what this system is doing. So I'm going to start off here with an interface we're defining called Assistant. Inside of here, we're going to set a system message, which is going to let the LLM know that it is supposed to be an API gateway and to talk to you in a friendly manner and give you concise responses. So whatever happens in our command, it's going to give you something back and do it in a nice friendly fashion. Our Ollama plugin that we're going to use, let's start off with the basic parts. We are going to use the Ollama chat model builder, which is just a feature coming out of the LangChain4j library that allows us to build up a chat model for Ollama. We set into it the URL, which is going to point toward our running Ollama instance, and tell it which model we're using. In our case, we're going to use Ollama 3.2. You can use larger models depending on the hardware you have available. And we can set things like temperature, timeouts, etc. Then we are going to use another part of LangChain4j, which is called AI services. It's a builder pattern, and it is going to allow us to build out the experience that we want to have with this LLM. We're going to build it out using the assistant class, which is based on our assistant we just built, this interface. So it's going to be aware of that one right here. And then we can set into it what's called tools. This tool set, it can become a collection of classes, but we're going to use it right now using a single facade. And what this will allow us to do is be able to decorate a bunch of calls that we have and tell the LLM what they are about. So you can imagine inside of our API gateway, we may have a endpoint that's for converting files to the new schema. Perhaps we have something that allows you to send events to some destination, a queue. Perhaps we have something else that would be very dangerous, deleting a database, but we have that one in there because it's going to throw a runtime exception all the time. And I want to show you how the LLM responds to exceptions being thrown. I've also included one here called no-op. So one thing I've noticed in working with the LLMs is that you have to be very, very precise in your descriptions, because the LLM are reading these descriptions of these tools, these method calls it has available to itself. And it may think that everything must fit to one of these tools. By providing it an out, it's kind of like a default to say, hey, if one of these above methods does not match what the user's requesting you to do, you have an out. You don't have to perform something with the incorrect inputs to be able to operate it. But these are all things you can tune and work upon with developing your application. So what is this doing overall? So we have now told the AI services when we run them, if the user in conversation with you asks or makes a request and it matches up with one of these methods, one of these requests they can work with, it can now delegate to this tool and then make those calls. So effectively, you've already done all the development work in your API gateway to do successful conversions. You're not asking the AI, hey, how to convert from schema A to schema B. You're saying, hey, I've already done that work. We've developed it over the years, debugged it. I just want you to be able to go and do this job for me when I ask you conversationally to work upon it. So let's take a look at what this looks like during a runtime. We're going to quickly build our code, which is just in the Maven project. So we'll build this up, and then we're going to deploy this into a runtime so we can see how this interacts. All right, so let's start our locally running Carafe. For those not familiar, Carafe is a OSGi-based runtime. It allows us to run our applications in a very friendly way for modular developers. So let's take a look at what we currently have installed. We have an API gateway and its backend installed and set up. We've already deployed the existing service. This is something just to show we can be talking to a service that's running in the system. And then we're going to install our just created bundle for the Ollama plugin. So we're going to install this Ollama plugin, and that's a capital. And we'll see that it is now here in the system. We're going to ask our AI command that we had previously discussed in our videos to talk to the Ollama tool. That is our new plugin. And we're going to start with just a very generic question. How is your day? And what we'll see is that the LLM will give us a generic reply back. Something that's really important here is that I've put in some system out prints in any of these tools just to see if they have been run. Just gives us a confirmation. Let's quickly see if this is using appropriate tools. So let's change up our question. We're going to first ask it to, can you please convert file ID, let's say foo123, and let's see if it's going to realize it needs to pick a tool that can do a conversion by a file ID. And here we see that it's that it wants to pick up a file foo123 and run through a conversion. You can imagine you may have an endpoint that would be get file by ID, and then another endpoint that would be convert this file into our new schema. This is how the LLM starts being able to understand this. Let's try another request. Let's see if we can get it to send a message. Can you send the message, hello world, to the IT department queue. Now, let's see if this will send it off. Okay, I forgot the D, but in here, it is sending the message to the IT department queue. It is adhering to what it's seeing here in my tool description. So it's able to figure out that this is an endpoint that can provide the back end to it. Okay, let's try a demo to try and get our exception be thrown when we requested to delete a database. It shouldn't be able to do it. So let's change our request now to, can you please delete database foo. And you can see that it did a request, it picked it up and said, hey, I want to delete foo. And then we get back an error saying this is not allowed. It's based on a runtime exception for the operation is forbidden. This is kind of cool, and we're now talking to a backend system that can start working with things in the backend. Of course, you're going to want to put all sorts of guardrails around how things can run here, and if you already have built an API gateway with a lot of that stuff already built in, you can start leaning in on your already existing code. But overall, yeah, this is cool. We've only had to add in a minimal amount of extra information here to tell the AI all about the tools that we have available in our existing gateway, and it's starting to be able to use them. This is really, really neat. I'd like to show one more quick demo here of the ability for the LLM to start even chaining these together. So say we're going to ask it, can you convert a file and then send that as a message to a particular queue? We'll see here when it runs, it notices, yep, let's convert this file ID to the new schema, and then we're going to send that updated one over to the provided destination, and then gives us back a bit of extra color about how this all worked, which is really, really cool, because you can start imagining when you have downstream clients that used to be able to say, well, you have to explain to them now, here's your API gateway, and you have to use endpoints A, B, C, D to be able to get to your result. What if you can just tell it to a nice front-end agent and say, hey, go ahead and do all these conversions for me, and when you're done, send us a note. This is cool. As per usual with our demos, we always like to put it up on our Savoir GitHub. We'll have a link to that in the show notes below. We'll also include in the show notes a link to LangChain4j and the tools feature, so that way you can take a look at their documentation and their extra examples. As per usual, please go on to our channel. We have lots of content coming out all the time. And please, if you haven't already, like and subscribe to the channel and hit the notification bell. We love hearing from you. And have a great day. Cheers.